Welcome once again, guys. So we're starting with this question. It was extracted from 1981 UTME, question 25. So the question goes thus. The driver in a motor car of which the total mass is 800 kilograms and which is traveling at 20 meters per second suddenly observes a stationary dog in his path 50 meters ahead. If the car brake can exert a force of 2000 Newton, what will most likely happen? A, the car will be able to stop immediately the driver notices the dog. The car will stop 30 meters after hitting the dog. The car will stop 20 meters in front of the dog. The driver will quickly reverse the car. The car will stop 5 meters beyond the dog. So now the first thing I always like to do when I'm trying to solve any question is to have a diagrammatic representation of what the question is trying to say. So for this question now, we have a car going in this direction. We have a dog. I don't even know how to draw a dog. Oh, pardon my dog. Go in this direction. Now they're saying now that the driver notices that the dog was like 5 meters away, and then they're not asking us that what will happen if the driver exert a brake at that 5 meter mark, 5 meter distance from the dog. So now the next thing I do after having a diagrammatic representation of what the question is trying to say in my head is to write out all the parameters that are given in the question. The first, because it is the parameters that are given in the question that you'll be able to use to actually solve your questions. Now, there are some parameters in the question that you may need to use to get another parameter before you now go ahead to use that parameter to get your answer. So we write out all the parameters that are given. So the first parameter we are given is what the mass, total mass of the car is 800 kilograms. Then they said the car was traveling at 20 meters per second. So that's the initial velocity of that car before it applied the brake. So that means what? Our initial velocity is what? 20 meters per second. Now, he said he suddenly observed a stationary dog in his path 50 meters ahead. Now, we will not necessarily use this 50 meter in what we do like next, but then it's best for us to write down every single thing. So you have 50 meters. Now, the mistake most people tend to make is they will assume that this 50 meters now is the S, is like the distance covered, but it's not. So you have 50 meters, which is it will be the distance between the dog and the car. So what else were we given? And then they said if the car brake can exert a force of 2000 Newton. Now the force in this case, which is the force of the brake, will be what? Minus 2000 Newton. Why is it minus? Because the force that a brake supplies is a negative force. It's the force that a brake supplies decelerate the car. So, and anytime you have deceleration is what is negative acceleration. So usually minus. So if you have a negative acceleration times the mass, it's going to give you a negative stuff. So that's why we have our force. The force exerted by the brake to be minus 2000 Newton. So now those are the parameters that we're given. Now, what are we looking for? Now, from these options, now you can have an idea that what they are asking us for is what distance covered. The distance covered between the point of applying the brake and where the car finally stops. So that's what they're asking us for. So that's the distance covered. So that is the S. It is not this that is the S. This is the S. The distance covered between the point of application of the brake to where the car stops. That is the S, not this. Well, I think that's one mistake most people tend to make. So now, since we have all the parameters that we're looking for now, we've written out all the parameters we are given and the parameters we are looking for. Now, the next thing we do is, what are the formulas that links all this together? Since we're looking for distance covered, what is the formula that links all these things together? We're looking for distance covered. So then you go back to what? This question is on motion. Now, another thing you should actually, when you read the question, the first thing you should think about is what? Which topic is this question from? So this question is from motion. And the first thing that should come to your head after identifying that this question is from motion is what? All the likely formulas that you will need to actually solve this. So for this now, this is a uniform motion. This is a uniform motion because the acceleration is what? Acceleration is constant. That's one condition. For a motion to be uniform, the acceleration has to be what? To be constant. So what are the and don't forget that you have equations of uniform motion. You have four of them. So the equation of uniform motion that we have, you have V equals to U plus AT. You have S equals to U plus V all over 2, everything times T. And then you have um, S equals to UT plus half AT squared. And then you have V squared equals to U squared plus 2AS. So now we have all these equations of motion now. So we have U, we're looking for S. So another thing we should do now is we cannot use this force that we're given directly because we are dealing with motion question. So that means we need acceleration. And since I said that this question is about what uniform motion, I told you that one condition that must be met for a body to undergo uniform motion is what the acceleration has to be constant. So you have to calculate the acceleration or the deceleration in this case. So don't forget that your force is equal to what? Mass times acceleration. Yes, we're given force minus 2000. We're given mass 800 kilogram times the acceleration which you are looking for. So your acceleration will be equal to what? Minus 2000 all over 800. So that will give you what? 2.5 minus 2.5 meter per second square. So now we have our acceleration. So now that's what I was saying, that there are some questions that they'll give you a parameter that you need to use to calculate another parameter that you are going to use to get to solve the question. So this is the kind of case. This is a similar case that we have here. So now we have our acceleration, we have our distance. We are looking for distance covered. We have initial velocity. Now there's also another thing that is missing here. That most people, but the mistake most students tend to make is when you see the question now, oh, they didn't give me all the parameters. I used to be there before I actually, after a lot of practice, I tend to I'm able to understand and then get it. Now there is a parameter that you are given here that you don't know that is there. And that parameter is what's your final velocity. Now, if a car is to apply a brake, now it's starting with 20 meters per second, then it apply the brake. And I told you that the brake that is applying is what is a negative force because it's decelerating the car. So if it is decelerating the car, and they are saying that if the car is at the sort of what most likely happen, if it applies a decelerative force, the car is going to stop at the end after covering a certain distance, which is the distance that I'm looking for now, which is this. So it's going to stop. Now, when the car stops, what is the velocity? Velocity is what? Zero. And since that velocity is the final velocity, it's like the end velocity, is the velocity that the car possesses after the application of that force, after the application of that acceleration, that will be the final velocity. So the final velocity that we are given now in this question, that we don't know that we are given, is what? V, which is equal to what? Zero. So now we have, so now we have, we are looking for this, we are looking for distance covered. We were given initial velocity, we were given final velocity. We've calculated our what? Our acceleration. So now the next thing you do is now, since you've written out all the formulas for equation of motion, because the first thing you did was to identify this topic, which topic this question was from. Then after that, no, the first thing you did was to draw a diagrammatic representation of the question. And after that, you write out all the parameters. After writing out all the parameters, then you understand which topic is this question from. And after identifying which question this topic is from, then you write out all the formulas that you may, some formulas that you may need. You don't necessarily have to write everything, because if you start writing everything, that will waste your time. You write out the important formulas based on what you the parameters that are given. Write out the formulas based on those things. Now, after writing that down, then you look for if there's any parameter you need to calculate from the parameter that you're given that may help you to actually solve the questions. You do that just like the same way we did here. And after doing that, you write that after you've written out all the parameters that you are given and then they are looking for, and you've calculated the ones that you may need. Now you come back to this question now. Now, which equation among all these links all of them together? Oh yeah. Now, which equation out of all of this? Now, which equation out of all of this links all of them together? It is what? This. Because you have what? V. You are given V. You have U, initial velocity. You are given initial velocity. You have your you have your acceleration, which is one you calculated here, and then you are looking for what? Your distance covered. So then you slot in all your values. As simple as that. V is what? 0 squared. U is what? 20 squared plus 2. Your A is what? Minus 2.5. Then times what? Times S. You make S out of the formula. Now, for those that probably don't know how to make the formula, because I understand I've been there, and it took a lot of work for me to actually get out of there. So what you do is what? Carry this to the other side, this to the other side, and anytime you carry it to the other side of the equation, you're going to turn it what? You are going to add minus. But then don't forget that you are going to do this squared before you carry it to the other side. So square of 20 is what? Is 400. So when you carry 400 to the side, you have what? Minus 400 equals minus 2 times 2.5 minus 5s. So divide both sides by what? Minus 5. So you have just s alone. So you have minus 5 minus 5. So you have what? S to be equal to what? 80 meter. So that is the distance covered between the point of applying the brake to where the car will stop. So now you're not going to do a separate diagram. Now, since between the point of application of the car of the brake to where the dog is 50 meter, and after the application of the brake, the car is going to stop 80 meter ahead. So that means the car will have hit the dog, and it will still move. It will still cover a certain distance before it stops. So the certain distance is going to cover before it stops. Now that's where this will now come in now. This 50 meter that we were given. So after hitting the car, after hitting the dog, it's going to still cover what? Between here and here. So you are going to subtract what? 50 from 80. It covered the bus before the car stops, it covers a distance of 80 meter. And then, whereas the dog was at the 50 meter mark. So that means the car will stop 30 meter. 50 minus 30, 80 minus 50 is what? 80 minus 50 is 30. So it cover 30 meter after hitting the dog. So now let's go back to the option now. We have the car will be able to stop immediately the driver notices the dog. No, the car will not be able to stop because we've already calculated that the car will only stop with this brake force. It will only stop 80 meter after hitting the brake. Now the bus will stop 30 meter after hitting the dog. That's the answer. Because what? Because it's going to the car is going to stop 80 meter after the application of the brake, whereas the dog is at what? At the 50 meter mark. So it will have like an excess of what? 30 meter that it will cover. So that's how you solve questions like this. I hope you understand this. Now there's a similar question that I have here. So I will drop it down in the comment section or the description. Try to solve the questions and then drop your answers and send your workings as well too. I will tell you whether you are right or wrong. And that will show whether you understand the topic or not. So if you have any other questions that you want me to solve or you want me to break down this same way, kindly drop them down in the comment section below, and I will ensure to make a video breaking those topics down into the tiny bits. Now, this question now, there are a lot of questions that are similar to it. I will drop a similar question to it in the comment section. If you understand this, you'll be able to solve that question. Now, I'm saying that when you are practicing past questions, you're not just practicing past questions to just know the answer. You are trying to understand the principle behind solving each questions, so that when a similar question is asked in the exam, you won't be finding it difficult to actually provide answers to it. So that will be all for now, guys. See you guys in the next video.